for a greatest common factor? And actually, the numerator and denominator both have a greatest common factor. That's going to make your factoring a lot easier. What can I divide out in the numerator? 5. So what do I have left when I factor out of 5? X squared minus 4. And so I'm going to take that one step further because I recognize that I have a sequence of squares. So how can I factor x squared minus 4? Remember, you take the square root of each part and one gets a plus and one gets a minus. So it would actually be 5x plus 2 and x minus 2 is my numerator factored. Is that good enough? So 5x plus 2, x minus 2. So I'm going to do the same thing in the denominator. What should I factor out of the denominator first? I'm actually going to do it underneath because I'm kind of running out of room. So I'm going to divide out a 3 first and kind of put it underneath. What would I have left when I divide out a 3? I'd have x squared plus, what would I have left from the 12x? I'm dividing by 3, 4x, and then plus 4. So now I'm going to take that and I'm going to factor it out over here. Because now I need to factor the x squared plus 4x plus 4 step. So this is a trinomial. So what method do I use for a trinomial? Diamond. So I'm thinking in my head, what are the factors of 4 that add up to 4? 2 and 2. So I end up getting x plus 2x plus 2 over here. So this is my factored answer. That was a lot of work. That was probably more factoring than I'm going to have you do because you had to do like 2 steps for each problem just to get to that step. I can factor one of these x plus 2's. And so what I said is you want to rewrite the function so that you're only looking at what you have left. You don't want to be confused by what you canceled out. This is the function that I'm going to answer all my questions about now. So the 5x minus 2 over 3x plus 2. So then you're going to use your note card to find y-intercept, x-intercept, vertical asymptote, horizontal or slant asymptote. So let's do this together because it's been another day. How do I find a y-intercept? Plug in 0 into the whole thing. All right, so I get negative 10 over positive 6. And actually, if you had done it over here in the original problem, see how you get negative 20 over 12? So you still would have gotten negative 10 6. What does that further reduce to? Negative 5/3. So 0, negative 5/3 is my y-intercept. So I can graph that. It would be just below the negative 1 on the y-axis. So like right here, negative 1 2/3. All right, what's my x-intercept? So now I only look at the numerator. What's going to make the numerator equal 0? When x is, so I've got 5, x minus 2. So what should go in where the x is? A 2. So my x-intercept, there's only one of them, and that is at 2, 0. So vertical asymptote, I only look at the denominator. So what's my vertical asymptote? Negative 2. See, because that x plus 2 would become 0. So x equals negative 2, vertical line at negative 2 on my graph. All right, now look at your step 4 on your note card. I have to compare the power of the numerator with the power of the denominator. These are both linear functions, right? Degree of 1. So what's the rule? When the powers are the same, you strip or peel off the coefficients in front of the x. So this is a 5x divided by a 3x, so 5/3. So y equals 5/3, which is what? 1 and 2/3. So right between 1 and 2, I have this horizontal asymptote. So I can see where one of my elbows is. I should check for a hole. Is this function going to have a hole? So I go back to the original function where I canceled things. What did I cancel out? I canceled out this x plus 2. So I would have been thinking, oh, this has a hole at -2, right? Because that would have been undefined. But we have an asymptote at -2. So if there's already an asymptote, there's not a hole. You can't have a hole on top of an asymptote. So there's actually no hole because see how it was the same factor twice in the denominator? So even though we canceled one of those factors, the other factor is still there, so it's still an asymptote. If you look back at example like 3, we canceled out the 2x minus 1 with the 2x minus 1. So the 2x minus 1 is no longer in this circled problem. That's why there's a hole where this would have been undefined. Or if you look up here, the x minus 2's are completely gone, so I'm taking into account that the original function was undefined. So I know one of my elbows is all set, like this. What value should I plug into my function to figure out the left side of the graph? My asymptote is currently at -2. Right? I want to figure out what's going on over here. So what x value should I plug in? What is to the left of -2? -3 or -4. So we have to plug in -3 into this function. I'm kind of running out of room here. Maybe I'll just do it so that you can see what it would be. I'm plugging in -3. So that would give me 5 times -5 on top, right? Because -3 minus 2. And then that would give me 3 times -1 on the bottom, because I'm plugging -3 in. -25 divided by -3 is positive 25 thirds. Positive 25 thirds. What, 24 divided by 3 is 8, so like just over 8, right? So that 8 1/3. You guys know the fraction button on your calculator? Oh, this is kind of a junky calculator because it's sticky keys, but if I do -25 on my calculator divided by -3, it gives me the decimal. I know that's 8 1/3, but if you hit math fraction, see how 25 thirds, 8 1/3. There are no calculators in here today because they're using them for the PSAT. But at -3, my graph goes through the point 8 1/3. So if I graph that point and kind of show that the elbow swipes through that region. So that's a really long problem, right? You had to factor it. You had to answer the 4-part questions, graph it, see if there was a hole. So there's like 2 of those for the quiz on Friday. Front page of the paper, back page of the paper. Just like the quiz this past week. So let's do another one of those together. And then a couple funky things happen in 2 and 3. Those are pretty quick. So I'll show you those and then we'll do kind of a walk. So let's see. Example 1 here. I need to factor and look to see if something is going to cancel. I can't factor the numerator, but I can kind of use this like backdoor trick for factoring now. I wonder if x minus 3 is one of my factors in the denominator, right? Because if x minus 3 is a factor, I could cancel. If it's not a factor, I can't cancel. What would this factor have to be to make it multiply and give you x squared right here? This would have to be an x, right? Because x times x is x squared. And what would this second term have to be to give you -6? It would have to be -3 times +2, right? So you can check your first and your last term, but you have to then do FOIL in your head to make sure that it really did factor into this. See how I get -3x and +2x? That is -1x. So it checks out that this does factor. Or you could use, the box or diamond method, but I like to look for the factors, like intentionally. So do you see how your x minus 3's cancel? Something I emphasized yesterday, make sure that you write a 1 in your numerator to show that the numerator is not 0. X plus 2 is in the denominator. You need to show that x plus 2 is in the denominator, or else it changes the function completely. Okay, go through. You do steps 1 through, well, you could try the whole. Take a couple minutes on your own with your note card and see if you can answer those questions. Maybe hold off on graphing that for a minute, or if you want to call me over to intercept. I plug in 0 and I get 1/2. So 0, 1/2, right? I look at the entire function, plug in 0 for x, I'd get a 1 up top and a 2 on the bottom. X-intercept, I only look at the top. That's fixed at a 1. So the numerator can never be 0. So there will be no x-intercept. Now I only look at the denominator. What will make the denominator 0 would be -2. So x equals -2 would be my vertical asymptote. Then I look at the power of the numerator, which is basically 0, right? X to the 0 power, there's no x's. And x to the first power is bigger in the denominator. So y equals 0 is what happens when your denominator grows at a faster rate, because it would be 1 divided by a very big number. Okay, then I need to look, is there a whole? So I look back to what I canceled out. What would have made this 0 in the denominator? +3 for x, because 3 minus 3 would have been 0 here. So I need to account for that with a hole in the graph. I take my 3 and I plug it into the circled equation. If you plug it into the crossed out equation, it's going to be undefined. So you want to plug it into the new equation and you'd get 1/5. So 1/5. So now that you know what all the correct collection of information is, why don't you see if you can sketch that on the graph? And then you might want to wait to do the domain and range for just a minute. All right. So let's see. We had 0, 1/2, no x-intercept, a vertical asymptote at -2, a horizontal asymptote at 0, and a hole at 3, 1/5. 1, 2, 3, 1/5. So it's kind of like this elbow is all in this top right region, right? Like that. So I've used all my information up, but I still don't know where my graph is on the left-hand side. So what would be a good value to plug in? Like this is -2. So what should I plug into the original equation? -3, right? To be over here. And when I plug in -3, I get what? 1 divided by -1 is -1. So at -3, my graph passes through the point -1 like that. So 2 opposite elbows is what I end up getting. This problem, I'm not going to ask you domain and range on your quiz on Friday, but I will ask you this on your test in another week. Domain is affected by both asymptotes and holes. So there are 2 values that x cannot be, -2 or +3. So the hole at 3 goes into your domain. Same thing with your range. There's actually 2 values that your y value can't be. It can't be 0 and it can't be at 1/5. So y cannot be 0 or 1/5. And that seems to be difficult for students figuring out domain and range. I wanted to show you number 2 because 2 is a pretty quick and easy problem. And I wanted to show you number 3 because 3 is also a quick and easy problem, and then we'll go for our walk. So number 2, the reason I say it's quick and easy, something interesting happens when you factor this one. So the numerator is difference of squares. How do I factor the numerator? So that's when one gets a plus and one gets a minus, and you take the square root. So what are the factors for the numerator? So x plus 2, x minus 2. If you notice, my x minus 2's can cancel. Well, now all I have is the function y equals x plus 2, which is no longer a rational function because now it has a 1 in the denominator. So this is what kind of a function? What is y equals x plus 2? It's just a line. It's just a line with a hole in it. So I wouldn't go through all these steps to figure out how to graph this. We know that this has a y-intercept at 2 and a slope of up 1 over 1, but we will need to find the whole on the graph. So if I start at 2 on the y-axis, here's 2. I go 1 over 1. Here's the graph of this line, right? It's not a rational function anymore. It's just a line, but it has a hole in it. Where does the hole go? So I look at what I canceled out. Where should this have been an undefined x value? At 2, right? So my hole is at 2, and I plug 2 into my new function over here. See how that's at 2 comma 4? So right here, you need to show that there's a hole at 2 comma 4. But a line does not have a vertical or horizontal asymptote. So it has none, none. It did have an x and y intercept. I can kind of find those afterwards. 0 comma 2 is my y intercept. What's my x intercept? Right here, negative 2 comma 0. So I guess if you have something cancel and you end up with just a line, you should be thankful that all you had to graph was a line. You didn't have to graph asymptotes and elbows, and it should be a pretty quick and easy problem. All right, so what's my domain? There's a hole though. So x can never equal 2, and y therefore can never equal 4. So wherever your hole is, that affects your domain and range. All right, so the last example I wanted to show you before we can go out for a little walk if you want. This problem is not set up to use your note card. To use your note card, it has to be one fraction with a numerator and a denominator. This is actually set up to use your transformation rules. And we did this at the very beginning of the unit, but we talked about how basically the two elbows should always be at 1, 1 and -1, -1, and they have asymptotes at 0 for x and 0 for y. All this does is it shifts it left and right, or it shifts it up and down. So I didn't want you to overlook an easy problem thinking it's harder than it is. If it says x plus 3, where should I go? Should I go left or right? X plus 3. Left 3. And what about this -5 out here? Down 5. So if I move my asymptote left 3, now I'll have an asymptote at -3. And if I move my asymptote down 5, 1, 2, 3, 4, 5. Now I have an asymptote at -5. And I can just dot kind of like one away diagonally from each of that center cross and draw your elbows. So I didn't really need to use my note card because I just go left 3, down 5, and the two dots go 1 unit away on either side. So this wouldn't be as good of a problem. I probably wouldn't have you answer like these types of questions up top because you'd have to combine like terms and make it one fraction to figure out your x-intercept. But I will say, what's my domain? X can never be -3. Y can never be -5. So at least if you could, write your asymptotes or domain and range.